Hello, this is video number 12, and the last several videos have actually been leading up to this, which is one possible solution to that oil field problem, actual C++ source code that, unless I did something wrong, it runs the way it's supposed to. This particular file is the main program, oilfieldtest.cpp. There's enough heavy-duty stuff in the files for this project that I think each file is probably going to get its own video. That's the plan right now. So I'm assuming that you have a copy either printed out or maybe in a separate window on your screen. You have a copy of oilfieldtest.cpp open that you can take a look at, and I'm going to do this just line by line. Of course, header comments. We've got to have header comments. IOStream, seen that on line 7. Line 9, include oilfield.h. Oilfield is a separate class that was written to assist with the solution to this. Just takes all of the ugly complication of searching for oil recursively and all that out of the main program. The main program, you'll notice there's almost nothing there. It ends on line 26 with return 0. So the main program itself is real compact, short and sweet. That's by virtue of having all the technical, gory technical details buried down in the oil field class. Line 8 is new. So here, I'll go by line number. I'll just start a list here. Line 8. Line 8, fstream. That just says that this is going to use disk file operations. Use disk file operations. Which is a great explanation if you know what the hey that's talking about. Normally we just use IOStream, input-output stream, which is by default input from the keyboard, output to the screen. We could also use text files, just plain old text files, .txt, sitting out on disk, and access those as we would, here's the cool thing, as we would cin and cout. We just rip out cin and put an input file stream variable in its place. And if we want to write to a file on disk, then great. Set up an output file variable and send things to that exactly the same way you would to cout. Oh, you know what? cin and cout, we've been using files all the time. Cin is a special case of an input file stream that's associated with a keyboard. Cout is a special case of an output file stream that's associated with the screen. So we really don't have to learn much new stuff except to remember to include fstream if we want to use disk operations. Got a lot of mileage out of one line, didn't I? Let's keep going. Main program, line 12, all the comments, all the comments. Line 16, I guess that's the next place we need to start paying attention again. Line 16, there we go. ifstream. That's not ifstream. That's short for input file stream. And I'll write that out. First time we've seen it. Input file stream. In other words, we are associating a variable with a file out on disk that we're going to be reading from rather than reading from the keyboard. So input file stream, and we're declaring a variable with name in file. You know what? I'm going to have to go back and review this stuff after I write it up here. Variable in file, and I'll even put a comma and keep going, associated with disk file, whatever name I have there, oil.txt. Okay, let me explain all the pieces. The ifstream out front on line 16, that's the data type. Just as int is a data type, string is a data type, ifstream is a data type specifically set up for input file operations, input file stream. It's called stream because it's a stream of bytes. It reads 1 byte at a time sequentially. Okay, input file stream. In file, there's nothing magic about that. That's any variable name I want to use. In file seemed like a perfectly good name because it's an input file. I could have called it input file. I could have called it oil input file, whatever. A lot of flexibility there. No flexibility with ifstream because that's a data type. And the constructor is expecting one parameter. The constructor for an input file stream object wants one parameter passed in, and that is the file to open on disk and connect to this variable. So everywhere that I'm reading from variable in file in my program, it's actually reading the next several bytes from oil.txt sitting out on the hard drive. New stuff. So now I'll be able to use in file as a replacement to cin. If I say in file greater than x, then instead of reading x, instead of pausing and reading x from the keyboard, it reads x from the input file. It's that simple. You might think, well, why do we go to all that trouble? We got by perfectly well with the keyboard. Well, maybe you're going to solve a maze that is 200 by 200. I'm going to go out on a limb and suggest you're not going to want to type in, what is it, 40,000 characters every single time you run your program to see whether or not it's correct. No, I don't think so. That's going to be sitting out on a text file, so you don't have to type it in every time. Next line 17. Lots of lines have new stuff. Line 17, that looks fairly innocent enough, doesn't it? Maybe? Oil field starts with a capital O. By convention, we know that's a homemade data type. In fact, yes, there is an oil field class. The header file was included on line 9. So we do have oil field available as a variable type, a data type. But look, we've got 2 oil field objects. This defines 2 oil field objects. Why do we need 2? Because we're only going to be using one at a time. Each oil field object, while we're using it, represents one region, one big grid as read in from the data file. And remember from the problem statement, the original problem statement, I tried very hard to be consistent with that. There could be several regions in there. It starts with the number of rows and columns, then the region of that number of rows and columns. Then another set of rows and columns, another set of pair of integers for row and columns, and then another region. We need 2 because we'll have the region that we are destroying, and by that I mean as we're searching for oil, every time we find oil, there's a 1 there in that grid square. We set it to 0. So by the time we get done with it, by the time we get done with our recursive search through a region for all the oil deposits, we've completely trashed the original that we read in from the file. It's all zeros. And rather than have to back up in the file and read that again, which is pain in the rear, rather than back up, we'll just keep a backup copy. That's why the second variable name is oil field backup. We make a backup copy so we can print it out later. The original oil field is going to get trashed, and I'm in a loop. So I'll move on. Speaking of loops, how about line 19? Line 19, while oil field dot read. Well, here's a couple of things in here. Apparently, the oil field objects, objects, I'm reverse engineering this because we can't see any of this yet. All this stuff is buried down in our header and implementation file. But apparently, oil field, which is there, a variable, notice the lowercase o. Lowercase o means this is not the data type. This is that specific object that was set up on line 17. Dot read in file. Oil field objects know how to read themselves from a file. How handy. Bury as much of that technical complication down in the class as you can. Oil field objects know how to read themselves from a file. S-E-L-V-E-S. From a file. From an input file, to be specific. A little bit redundant, but still, I'm striving for clarity. They know how to read themselves from the file. Therefore, we can just call read. Go read yourself from this file that I opened for you. Now, notice we didn't open the file down in the oil field object because there could be, I mean, it's not too hard to imagine. There could be more than one file that has different regions in it, and maybe the main program wants to read from several different files. After it's got the file open and associated the disk file with the variable, it'll be able to pass that in to the read member function, specifically a mutator, on an oil field object, and it will read itself from that file. Now, the reason a while loop there, not only can it read itself, it's going to tell us whether or not it was able to successfully read from the file. And again, I mean, you're going to have to keep in mind all of that stuff we looked at with that oil field problem specification earlier. It was row, columns, and then the region. Rows, columns, and then the region. Yada, yada, yada. Sentinel at the bottom, rows and columns are both zeros. So it's possible when we call read over and over on the same input file, it's possible there are several in there, and the way it knows to quit is when it runs into rows and columns that are both 0, in which case it will return false. There was no more region for me to read, and that's what that while loop is testing. So line 19, they know how to read themselves from the input file. That's part of line 19. What it's actually doing is keeping going. The while loop is while there are still regions to read, where a region, that's the word I'm using for the whole thing, the whole exploratory oil field place, where we're looking for plots and pockets and all those words that I don't remember. But while there's still additional regions to read, we keep going over and over again. And you might recall, or maybe you don't, that while loop there, the way it's set up, that is exactly equivalent to while the return value from oilfield.readIn file equals true. It's a Boolean function, returns true or false whether it's successful or it fails. So as long as it's successful, that's checking just to get the return value is true, then we're in business. So let's look for some oil in there. Okay? Line 20. Line 20 looks innocent enough. It's just a simple, straightforward assignment statement. Oil field backup. It's even choking me up. Oil field backup equals oil field semicolon. That deserves a yikes. Yikes! How is this possible? Question mark, exclamation point. That's a homemade data type like a linked list. I don't think we've ever tried to say slist1 equals slist2, have we? Maybe we haven't, I forgot. But if we're going to use this simple, straightforward little single equals, which is the assignment, it's not even a comparison, that copies oil field into oil field backup, then we have to teach the compiler how to do that. How do we teach a compiler how to do an assignment? I'll put in parentheses down here. Hint, operator overloading. You'll recall we have that pair of functions, the public wrapper and the private overload. There's a reason it's called a private overload. Typically it will have exactly the same name as the public wrapper, so it's an overloaded function. We've got more than one function with exactly the same name. When you overload an operator, such as the single equals operator on line 20, you provide additional definitions for what that single equals even means. The weirdest thing probably in this entire example is going to be that single equals there is actually a function call to a member function inside the oil field class. Why would we want to overload the single equals so that it calls a function? Because I didn't write it on the board. To copy from oil field into oil field backup, it's got to copy the number of rows, it's got to copy the number of columns, it's got to copy that entire grid, the bouncy wall and all the oil and everything. That's not going to happen automatically with the homemade data type. We have to tell it one piece at a time. Copy this, copy that, copy the other thing. So we've got to get inside a member function and look at all the stuff and copy all the stuff over to another object that's just like us, the same data type. All of that is going on behind the scenes, but it cleans up nicely, doesn't it? On line 20, it's just a simple, innocent looking little single equals. There is so much stuff going on behind the scenes. But I'm going to put this off. Rather than talk about that here, that is such a can of worms, I'm going to put that off for a future video. Not worry about that right now. Moving on, line 21. What's line 21 doing? Line 21 finds and returns the count of connected deposits in the current oil field. Finds and returns the count of deposits, and if you remember the terminology, a deposit is a bunch of connected pockets, where a pocket is one of the grid squares that has actual oil in it. Finds and returns the count of deposits. And instead of saying current oil field, I'll say in this oil field. And I'll use capital O, this oil field object. Object with a V. Finds and returns the count of deposits in this oil field object. When it calls find all deposits, notice it's already read it in. It's already got the grid. It already knows where the oil is in each one of those little grid squares or absence of oil. So on line 21 at the end, called to find oil deposits, it doesn't need any parameters. That's just saying, okay, now get your button gear and get in there and find out where all those oil pockets are and connected. And while you're at it, count up how many connected deposits there are. Pardon me. And when you're done, get back to me. And when it gets back to us, it prints out. Oil field with a lowercase o is a specific object. When we get back, it prints out from line 21 how many deposits it found. Now, I'm going to drop down and do a sneak peek at the session down there, where that's run with a specific oil.txt file. Look at that. The last one is interesting. On mine, on line 51, it says 5. Back up. It prints out deposits, colon. I'm on line 21, and it's producing line 51. Deposits, colon, and then that 5 is the return value from the call to oilfield.findAllDeposits. So apparently, it found 5 deposits in that particular oil field for that current value of oil field, that current oil field object that it read in from the input file. All these pieces we've got to keep in mind at the same time. And then there is no end line at the end of line 21, so it still keeps going on line 22 in this oil field, colon, and then it prints out the oil field back up. So line 23, is that the next one to pay attention to? Line 23, I'm just going to put a note here. We need to print the backup copy and then parenthetically ... because the original got trashed when we were searching for oil. Because BC, because the original ORIGINAL got trashed in the search. Close parentheses. Let me read that back, see if it's even coherent. Need to print the backup copy that we made before we even started searching. That was done back on line 20. So when we get back and we found all the deposits, that means that the oil field itself, the original oil field variable with the lowercase o, this is nothing but zeros now, because we searched that high and low and found all the deposits, and as we were going, remember, we were setting to 0 so that we wouldn't come back and count the same squares more than once. So that's nothing but zeros. There's no point in printing that out. We print out the original, which is the oil field backup. Bottom of the while loop, it goes back around and tries to read another one by starting to read the row and columns of a region inside the input file. And if it is possible to do it, then it goes through the whole thing again. Then we've got a new oil field represented in the oil field lowercase o variable, and we copy that and then trash that as we're finding all the deposits. And you can see that session down there, there were actually 1, 2, 3, 4, 5 different regions in that particular input file before it ran into the 0 row, 0 column. Okay? Oh, one thing I meant to mention up here, a parting thought. Input file stream. What if I want to send output to an output file? It's almost the same, but it looks like of stream, OF stream. OF stream, I'll put that in a different color. That's not technically part of this discussion. But before I forget, aside OF stream If we want to use either one of these, we're going to have to include fstream on line 8, or not necessarily on line 8. We have to include it at the top of the program. OFStream means output file stream. Output file stream. And with that data type, we open a file that doesn't have to exist in advance. We open a file. If it doesn't exist, our program will make a new file with that name out on disk and write all the stuff to it that we send to it, just as we would send it to cout. Now, we actually need to be a little more careful with OFStream, because if it does already exist, then it's gone. As soon as you open it for output, then it wipes out the earlier version, even if your program crashes. If you open an output file stream, boom, the next line your program crashes, then you've already erased the earlier copy of that file out on disk. So if I had oil2.txt, for example, that I want to send my results to, then as soon as I open oil2.txt for writing, it's been blanked out. It's an empty file until I start sending things to it, regardless of whether or not I ever send anything to it. That was a lot more than I wanted to say about the aside, but still, what can you do? I think that's probably enough for the main. Let's look at the class stuff. So I'll see you online.